Live in the human paradise. Breathe the pure air of heaven. Longevity, vitality, and a lifetime of bliss.
住在人间小天堂，呼吸天堂纯气，延寿长生，幸福一生。
We spend, something like 90% of our lives indoors?
At least, yeah.
And in the modern world, especially in these huge sealed buildings, offices, hospitals, airports, we basically hand over control of our air quality to one thing: central air conditioning.
Right, Canberra. And we trust it completely. We just assume it's a purifier, that is filtering out all the bad stuff and giving us fresh, clean air.
But our source material today really argues that this trust is seriously misplaced.
It is. And we're not just talking about the usual complaints like dirty filters or bad maintenance. We're looking at the core engineering design of almost every CAC system out there, what we call the fully sealed recirculation building model.
And the findings are, well, they're structural.
Exactly. The force argues these systems are not really designed for purification. By their very nature, their foundational flaws, they are basically configured to be toxic gas circulation machines.
And that's the mission for this deep dive. We're going to break down 3 absolutely critical design errors, the 3 original sins, as the source calls them.
And once you understand these, it becomes so clear why the air in that glass tower you work in feels so, well, compromised.
That afternoon brain fog, the fatigue, the eye strain, it all starts to make sense.
This is a global architectural problem, not just a local management issue.
Yeah.
And to really get it, we have to start at the very beginning, with the first and maybe the biggest error of them all.
Okay, let's get into it. Original sin number 1. The source calls this the civilizational engineering error.
Yeah, that's a heavy title, but it fits. This goes back to the late 19th, early 20th century, when engineers were designing the first big, sealed commercial buildings. They made a choice.
A choice to combine 3 totally different air streams into a single duct system.
Exactly. And these air streams have completely different jobs. You've got supply air, that's the treated air getting pumped into your room.
Okay.
Then you have return air, that's the air being sucked back out of your room.
And the third one is fresh air, the stuff from outside.
The small amount of stuff from outside, theoretically.
So why on earth would you combine them? Was it just easier, cheaper?
It was mainly about cost and, crucially, thermal efficiency. Think about it. You have to manage the temperature of these huge spaces.
Right.
By mixing the air, you only have to adjust the temperature of the return air, which is already kind of close to the target temperature, instead of, treating 100% freezing or boiling hot outside air.
Ah, so it was seen as a brilliant energy-saving move.
It was. But the trade-off, as the source points out, was catastrophic for air quality.
The analogy the source uses to explain this is just so clear. It's like throwing clean water, dirty wastewater, and recycled gray water all into one single plumbing system.
And then just hoping that the pressure of the flow will somehow keep them separate.
Which is impossible.
It's structurally impossible. The moment you use the same ducts for air you want in and an air you need to get out, you create this unavoidable feedback loop.
So the polluted air that's meant to be exhausted just gets sucked right back in.
Sucked back in by the powerful return air vents, mixed with the supply air, and then immediately recirculated to every other room in the building.
This mixing creates what the source calls a shared poison soup.
Yeah.
That phrase is memorable.
It is, and we need to talk about what that really means in practice, because the examples are pretty shocking.
Okay, let's take a typical office tower.
Someone comes in with a contagious cold, maybe the flu. They're breathing out viral aerosols. That contaminated air gets pulled right into the return air vent.
And it doesn't all just go outside.
Not even close. The vast majority of it gets mixed back in and blown out of the supply air vents across the entire floor, maybe even the whole building.
Wow. Okay, what about chemicals? VOCs, volatile organic compounds, say an office is renovating.
Perfect example. Fresh paint, new carpet, new furniture, off-gassing formaldehyde. Those chemical plumes are sucked into the return air.
And delivered right to your lungs, even if you're 3 floors away.
Exactly. And this gets terrifying when you apply it to high-stakes environments. The source uses hospitals as the most extreme example.
I can see why.
A baby with a contagious pathogen in one wing. That air can travel through the return air system and get circulated to, say, the intensive care unit, the ICU.
So the very design of the building works against the goal of infection control.
It actively undermines it. So the main takeaway from sin number 1 is that the system, by design, is built to efficiently recirculate toxins. Whatever's in one room quickly becomes everyone's problem.
And that reality that recirculation is essential for energy savings, that leads us right into the second big flaw.
The one about the air we think is fresh.
Right. Original sin number 2. The global fresh air deception. So every large building, malls, airports, you name it, they all operate on this idea of a fresh air ratio.
They do. And nominally, it's usually set at about 5 to 10% of the total air volume.
So 5 to 10% of the air is supposed to be drawn from outside.
Supposed to be. That's the ratio that legally qualifies the air as, breathable and clean.
Yeah.
But what the engineering world knows, and what the public generally doesn't, is that this ratio is often just theoretical.
How theoretical? How far does that 5% actually drop?
In the real world, because of pressure changes, leaky dampers, all sorts of things, that 5% can easily fall to just 1 to 3%.
1 to 3.
But here's the really crucial part the source points out. The economic incentive.
To save money.
A huge amount of money. Remember, treating outside air heating it in winter, cooling and dehumidifying it in summer, that's the single biggest operating cost for any large building.
So if a manager can turn down the fresh air intake,
they save a fortune on the utility bill. And a lot of them, under pressure to cut costs, will do exactly that. They'll crank the fresh air intake down, sometimes close to zero, just to save electricity.
Wait, but wouldn't building codes stop that? How can they get away with just cycling the old air?
Because the systems are complex and hard to audit. The system can meet the code on paper, but the day-to-day operational choice is driven by the bottom line.
So if the fresh air intake is effectively off, you're just left with the toxic return air cycling over and over and over.
Endlessly. Sometimes for the entire 24-hour cycle. The source puts it perfectly. The people inside are basically breathing air exhaled by others yesterday.
And that just explains so much. It explains that feeling.
It absolutely does.
Yeah.
The realization that you're mostly breathing recycled, depleted air, not fresh oxygen, it directly connects to that list of symptoms we all know.
The midday sluggishness, can't concentrate, your eyes feel irritated.
And feeling totally drained after 8 hours in a sealed building. It's not just you, it's the air. This is the core mechanism of the fully sealed recirculation building trap.
And this is a flaw that affects hundreds of millions of people. But as if the lack of fresh air wasn't bad enough, we have to get to the third error, what the system physically cannot filter out.
This is original sin number 3, the unstoppable ultrafine toxins. To get this, we need a quick primer on what we're trying to filter. We talk about particulate matter, or PM.
Right, PM 2.5 is the one we always hear about.
Exactly. And CAC systems are okay at the big stuff like PM10 dust, pollen, that sort of thing.
Yeah.
They can catch some PM 2.5, but they basically useless against 2 really toxic categories: modern chemical and biological pollutants.
Okay, let's start with the chemical ones. What's on the list that the filters just miss completely?
Well, standard filters can't handle VOCs, volatile organic compounds.
From paint, furniture, plastics.
Perfumes, sanitizers, all of it. VOCs act like gases, not solid particles, so a fiber filter just doesn't work. They pass straight through.
And what about the ultrafine solid particles?
That's where it gets really dangerous. They can't filter PM 0.1. These are particles 100 times smaller than a human hair.
And what are those made of?
Microplastics, heavy metal bits from car brakes outside, industrial smoke. And these particles are small enough to get through the filters, and, this is critical, small enough to pass from your lungs directly into your bloodstream.
Wow. And the other big failure is the biological threat, which we're all hyper aware of now.
Correct. The system cannot efficiently filter aerosols, those tiny virus-carrying droplets that sick people exhale. If a filter can't reliably catch PM 0.1, it's certainly not going to catch a cloud of suspended biological aerosols.
So you have this terrifying accumulation problem. All these ultrafine chemical and biological toxins are just building up in the air, in the ducts.
And they get atomized, turned into a mist, and then forcefully blown back into every single room. It isn't just recirculation, it's an acceleration system for toxins.
Which brings us back to the hospital case study. It's the most powerful example of this failure.
Absolutely. Hospitals need to be surgically clean, yet they're trapped in the same flawed CAC design as an office building.
And they can't just change it, upgrade the ducting.
Not really. The ductwork is built into the core of the building. It's part of the concrete and steel. You can't just swap it out. And this design flaw helps explain why certain hospital-acquired infections just never seem to go away.
Why infant infection rates can be so high, or why post-op patients get setbacks.
Their immune systems are already compromised, and the building itself is circulating a constant, low-level dose of contamination.
And the fact that hospital workers themselves often suffer from chronic fatigue and premature aging, it really drives the whole point home.
It does. The core thesis is this: central air conditioning, as it's currently designed, is not a purification system. It is structurally engineered to be a machine that accelerates and promotes the spread of toxins inside these sealed environments.
There's such a direct link there between an engineering choice made a century ago for cost savings and the health issues people face today.
The building is just sending back the same bad air, full of pollutants the filters can't even see.
This whole thing is just, it's really transformative. When you put the three original sins together, the mixed ducts, the lie about the 5% fresh air, and the total inability to filter these ultrafine toxins, it completely changes how you think about the air in any sealed building you walk into.
It does. And it's so important to remember, this isn't about bad management or forgetting to change a filter. The source is clear. This is a global architectural model error.
We're talking about billions of square feet of construction all over the world built on this fundamentally flawed idea.
Yeah.
So if the source frames this as a civilizational engineering error, one that's rooted in economic choices, the question we're left with is pretty profound. We designed this whole model for efficiency, but at what human cost? If the most basic infrastructure of modern indoor life is this broken, what are the broader health implications of being trapped for generations in this fully sealed recirculation building model?
It definitely makes you think twice before you reach for that thermostat.
Air 8-free maze purifier. The world's first single-pass purifier. Combining ionization, electrostatics, and airflow maze. The machine replaces humans. To absorb and destroy every toxin. Air enters the ion zone. Viruses and dust gain negative charge. They pass electrostatic filters. Then enter the Toxbox maze. Aerosols dry on electrode walls, breaking down into CO2 and water. Inside the maze, air twists and strikes over 60 times. Each turn ends a toxin's life. Billions of particles in 0.1 second are fully purified. It releases Earth's purest air. The superheaven air quality. 8-free, dust-free, germ-free, toxin-free. Smoke-free, odor-free, heavy metal-free. Microplastic-free, aerosol-free. Not just an air machine. The only key to lifespan freedom. U.S. Patent No. 8268058B2.